The Heisenberg Uncertainty Principle. It's a revolutionary idea in the field of quantum physics. In simple terms, it says that you cannot simultaneously know the exact velocity and exact position of any object. Everything in the universe, an apple, a cat, and even the computer you're watching this video on, acts as both a particle and a wave, whether you notice it or not. Particles exist in a single place in space at any instant in time. On the other hand, waves can exist in multiple places at once rather than just a single point, since they're a disturbance in space. On a wave, we can also identify its wavelength, which is related to the object's momentum as seen in the equation P equals h over lambda. In this equation, P is the momentum, h is Planck's constant, and lambda is the wavelength in meters. As you can see, the wavelength and the momentum are inversely proportional, so as one value increases, the other decreases. Most objects in our daily life have a relatively large momentum, which corresponds to a very small wavelength, and this is why we don't often see wave behavior for macroscopic objects. However, microscopic objects like electrons and photons can have wavelengths big enough to detect and measure. So if we have a wave, we can measure its wavelength, which we can use to find out its momentum. But a wave still has no exact position. We can find out a particle's position, but it doesn't have wavelength, so we don't know its momentum. If we want to know both the momentum and the exact position of an object, we need to combine wave and particle behaviors into a single graph. This would look like a wave, but in a restricted area. So how do we create a graph like this? Well, we can by adding multiple waves together. Thanks to a phenomenon known as wave interference, some parts of the waves add up to create larger waves and other parts cancel out. So we see some regions of waves separated by other regions where the waves canceled out. The more waves you add, the narrower the wave regions become. If we add enough waves, the regions of waves become a wave packet. This is a quantum object. But in order to get this quantum object, we have to give up our certainty of both its position and its momentum. If we want to be more certain about its position, we need to make a smaller wave packet by adding more waves, which makes its momentum more uncertain. If we want to be more certain about its momentum, we need to add less waves, which would result in a bigger wave packet and less certainty about its position. This is the Heisenberg Uncertainty Principle. The more you know about either the position or the momentum of the object, the less you know about the other. The uncertainty principle is the fundamental property of the universe and the result of the wave-particle duality of all objects.